And we can take these and write them as mixed radicals. So before we get to example 2, right at the top of your page on page 97, I want you to write the following down. We're going to make a powers chart. And the way that it's going to look like, it's going to go across like this and down like this. And we'll go powers of 2, powers of 3, powers of 4, powers of 5, powers of 6, powers of 7, powers of 8, all the way to 9. And above this one, we'll write, this is the base. And along this side, we'll write the exponent. And we won't do exponents of 1. Everybody's okay with like 2 to the 1 is 2. 3 to the 1 is 3. 5 to the 1 is 5. So we're going to start with squaring. Are you okay that 2 squared is 4? 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81. These are very, very important numbers for simplifying square roots. If we are dealing with cube roots, I'm going to color code them. Cube roots I'm going to do in green. 2 cubed is 8. 3 cubed is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And chances are you won't have to do these bigger ones. But I'll write all the cubes in. 343, 512, and 729. Then when we get to powers of 4, I won't be filling in all the chart because you only need to know certain ones, mental math. And for powers of 4, usually it only goes up. You'll need to know 16. You'll need to know 3 to the 4 is 81. And 4 to the 4 is 256. You won't have to know 5 to the 4 without your calculator. 3,125. And then once we get to powers of 5, (32), 3 to the 5, 243, and that's about it. Can you see that the only one that you could probably keep going at easily is the powers of 2? Because you can just double the next one, 64, double the next one, 128. So I'll write a couple more, but the main ones that we're going to be using is our exponents of 2's, because that will be related to, off to the side, I can think of square roots, and the powers of 3 are going to be important for cube roots. And the reason those square roots are important is because I might say, like in our chart with square roots, we made families. What family does square root of 72 belong to? So this is where our mental math skills will come in. We're dealing with square roots. We have to find the biggest one of these perfect squares that divides 72 nicely. The biggest one. 9 divides it nicely because it's 9 times 8. But 9 isn't the biggest one. 36 is the biggest one. So when we want to do this quickly, we will say, well, I know 72 is 36 times 2. And this I can reduce, because it's one of my perfect squares, to 6 root 2. All right, so I can say, all right, well, what family does the square root of 48 belong to? And so we have to go, what is the biggest square that divides 48? Okay? And there's not that many to check. In fact, if you start big, well, 81 is way too big, right? The closest one, even 49 is way too big. Does 48 divide nicely by 36? No, because the nicest it could do would be 2 times 24. 24 is not listed, so the first one I'd have to check if I was working down is really 16. And sure enough, 48 is 16 times 3. So you notice when I was looking for the biggest one, I started big and went down, okay? So that means that square root of 16 happens to be 4, so as a mixed radical, the square root of 48 is part of our root 3 family. But sometimes you don't see the biggest one, or you ask yourself, well, what happens if I accidentally missed 16? But I saw, because, here I'll just scroll up a little bit, I saw it was 4 times 12. So sometimes a student will start with the square root of 48, and they'll say, I noticed 4 works, and 4 is a perfect square, so I say it's part of the root 12 family. This isn't wrong, but it's not simplified completely yet. Because what can you do with 12? Is there something in our perfect squares that divides 12? Yes, 4 again. So then, if I didn't see the 16 and I started with the 4 and I got to root 12, I'm not done, because root 12 can be broken down even further to root 4 times root 3. And then I would have a 2 here. I'm going to put this 2 in brackets, because if I don't put it in brackets, it's going to look like 22. And then root 3. And 2 times 2 is 4 root 3. So if you don't see the biggest one, it's not wrong. It's just a little bit more work. So if we can see the biggest one early, that's going to be better. Can you see that we could have said the same thing with 72? If you see the biggest one, it's 36, boom, you get 6 root 2 right away. But so many of you, when you see 72, will think of 9 times 8 first. Can you see that? When you see 72, does your brain hit 9 times 8 quicker than it hits 36 times 2? No? Some people, yes. So if you did that, you'd be like, oh, it's my root 8 family. But then root 8, does it have a perfect square? Yes. It's root 4 times root 2, so it'll be 3. This is 2 times by root 2. 3 times 2 is 6. So I got the same answer. It just took a little bit longer. So this is the technique with square roots, how we would want to change from an entire radical to a mixed radical. Now in example 2, it's looking at cube roots with a fraction. And it says write it as a mixed radical. So for part A, I'm going to rewrite it here. I'm going to erase the work that we did. We'll go to part A here. And we had started with cube root of negative 16 over 135. So first of all, we can separate this and try to do the top and the bottom separately. And now that we're doing cube roots, we're going to look at the green line in our powers chart? Is there a number in the green line that divides 16? And I guess if you work from big down, it doesn't, you've only got one option. The only possible one that you'd have to check is 8. Does 16 divide by 8? Yes. So we can write this as the cube root, and generally with a cube root, does it make sense that a negative times a negative times a negative is negative? So I'm going to put the negative with the 8, which leaves me with a cube root of 2. Next, we have 135. 135. When you're working your way down, there's not that many to check. Doesn't work for 125. 64, go nicely into 135? No. 27, maybe. Okay? 27 times, does it work? Might have to go to our calculators. 27 times 5, right? So we would have the cube root of 27 times the cube root of 5. The cube root of negative 8 is negative 2. Cube root of 2 over cube root of 27 is 3. Cube root of 5. So this would be simplifying it as a mixed radical. Now, for me personally, I don't mind it right now if you leave it like this. The textbook answer had re-put this as a number in front and this as an entire radical with a fraction inside. At this point, either one is fine. Later on, both would be considered not finished. We'll learn about that later on. Because later on, we're going to learn that in mathematics, we do not leave any radicals in the denominator at the bottom of the fraction. And we have to learn a way to get rid of them out of the bottom of the fraction. But for right now, it's perfectly fine. So when you're dealing with cube roots, you're going to have your powers chart in your head to check. Really? Which ones, I can tell you, for cubes, because the numbers get big, as far as mental math goes, this is like probably all you'll have to check. Maybe those ones would be in there. But mental math-wise, there's not that many because otherwise the numbers get big very quickly. If we look at part B, we go to the fourth roots. So that's going to be down in our blue one. And in B, they start with the mixed radical, which is negative 3, fourth root of 2 over 27. And they want to write it as an entire radical. And first of all, we have to talk about the negative. Okay? Negatives only appear inside of odd radicals. If the index is a 3, a 5, a 7, then you can have the negative inside. Did you know that you can't square root a negative number? If you try it on your calculator, it gives you an error. You can't fourth root a negative number, sixth root a negative number, eighth root a negative number, even root a negative, eventh root, no, I don't know. Can't take the even root of a negative number. So the fact that this is an even number, number 4 is an even number, with a negative is going to continue to stay out front. But our first job is to change the 3 to something as a fourth root. And this is where our powers chart comes into play. Powers of 4. What is the power of 4 for 3? It's 81. So we can change and rewrite the 3 as the 4th root of 81. Now, I can take 81 and I can think of it as a fraction. And how do you multiply? Because now we can put this together as one big 4th root. Now, how do you multiply fractions? You multiply the tops and you multiply the bottoms. So some of you will take this and do 162 over 27. But then we need to have our fraction in lowest terms. So for me personally, when I'm multiplying fractions, I always look, is there something I could simplify early? Because if the earlier you simplify a fraction, the easier the mental math. And I noticed that 81 and 27 are both powers of 3. So 81 divided by 27 is perfectly 3 over 1. So I would simplify that first, and then when multiply my fractions, what am I left? I'm left with 3 times 2 and 1 times 1. Can you see that that is just going to be 6? So these ones I want you to try some from your homework. So try questions 3, 4, 7, or 8. 7 and 8. We've only got about 5 minutes.